Hello, everyone. So today we have Dr. Syafiq with us today. And Dr. Syafiq is the current chairman of the Malaysia IMO Committee. He represented Malaysia in the 2009 International Mathematics Olympiad and went on to study mathematics at Imperial College London under a government scholarship. He then obtained his PhD from the University of Oxford and teaching mathematics in Oxford before returning to Malaysia as a lecturer of mathematics at the National University of Malaysia. Hello, Dr. Shafiq, and thank you for joining us here in AMISO.
Hi everyone. Nice to meet everyone.
So, can you tell us a bit about Malaysia and the national selection test for IMO?
Okay, so before I begin, I'd just like to say that this I've been the chairman for the Malaysia IMO Committee for about 3 years, so it's relatively new to me. And prior to my term as the chairman, the selection test was very different. It was vastly different. And when I started being in charge of the Malaysia IMO program, we decided to revamp it uh, here and there. So usually before this, we had the OMK as a selection test, but at one point OMK was cancelled because of the pandemic. Unluckily, I had to be the chairman during the pandemic. But we still had to choose representatives to the IMO. So instead of doing the OMK, we created a new competition called IMONST. And IMONS has been the selection test for the IMO so far. Well, we only had two IMONS uh, to date, and we're still tweaking it here and there to make it work for everyone. Uh, but the long term plan is to stick with IMONS, and so that's the progress with the selection test. I will talk about IMONS later on during my in my slides.
Yes, I think you can show us a bit about your slides and the
Okay,
IMO.
so can you see my slides? Okay, so what I'm going to talk about today is about Malaysia and the IMO. So the participation of Malaysia in the IMO and the participants and our achievements and the selection process. Okay, so this is my talk. So first, I would like to talk about us, the committee ourselves. So who are we? So after I returned from the UK, after my DPhil, my PhD, I was elected as the chairman of the Malaysia IMO program. So we were elected by the Ministry of Education, KPM, and KPM provides the fund to run the IMO program in Malaysia. So it's not a big fund, but we still have to make do with raising funds ourselves because um, the program itself is a big program in Malaysia actually, and we have lots of training camps, and we need to get trainers and all the materials and all the how do you say the platform for the training. So all of these are done online now, so that saves up a bit of fund. We don't need a huge fund for that, but maybe in the future when we are allowed to do face-to-face camps, it would be a bit more expensive. So we are also looking to raise fund to run the IMO program. So
Dr.
the community is also assisted by the IMO trainers. So who are we? So that's me, Syafiq Johar. So I'm currently a lecturer at UKM. I was a participant in the IMO in 2009, and I can kind of relate to what's going on at the moment because in 2009, if you remember, there was also a global pandemic, but not as big as COVID-19. It was a H1N1 pandemic. So 2009 was a difficult year for us as well. So I didn't get much training, and we had to pay for our flights on our by ourselves. And it was kind of like a difficult experience for us. So, but yeah, it's compared to what we are going through now, that was not as difficult because at that time the IMO was still done on site in Germany. But now, in the past 2 years, all of the IMOs has been done have been done online. Okay, and we also there's also Mr. Shamil Ahmad Shakir. So he's a lecturer at KGI, and he is the IMO coordinator. So he's responsible for the communication between us, the team, and also the ministry. So there is a lot of communication going on between our team and the ministry. So we need someone to be, how do you say, to liaise our well things between us. So the ministry. Understandably, there are not that many people who understand what we're doing. So we need someone in the middle to know what we're doing and to know how the ministry work so that we can kind of work together. And then there's Mr. Suhaimi Ramli. Of course, everyone knows Mr. Suhaimi. He's an IMO trainer and he runs his own company now. He was in the IMO for 3 years, 1999 to 2001. So he has been very experienced with the IMO. And he's been involved with the IMO training program ever since I was a participant. So I met him at my first camp in 2009 or 2008. And we've been, yeah, we know each other since then. So we've been very good friends since then. So he was my trainer and now he's my
Oh, okay.
colleague.
Yeah, so he was your trainer, but you are the chairman of his committee.
Yeah, I kind of took over his position. So he was a chairman before this, and he's been a chairman for more than 10 years, 20 years. No, 10 years, sorry, not 20 years. So he's been involved with training since 1999 when he was a student. Yeah, so he's been involved and managing the IMO uh,
Since when you
things
started. Yeah.
for 10 years. Yeah, so yeah, he wanted to pass on to someone else.
So like
So
the third or fourth generation of the IMO committee.
yeah, kind of. Yeah. So he was my trainer, and now I'm in the future. I'm probably going to pass it down to another student. Yeah. I mean, it's a heavy responsibility. So I can imagine why he wanted to
Yeah.
pass it on to another person, the younger people, to do it. Yeah. After I've been managing it for three
So you
years, two
basically
years.
the committees are the alumni of the IMO itself.
Yeah.
Are they? Yeah.
Yep. But it's not a huge committee, so we could use with more help, I guess. And then there's Mr. Zafri. He's been also an IMO trainer for a long time as well. So I remember I've met him probably like yeah, well, when I returned to Malaysia, and he's been involved in the IMO continuously since then. And currently, he's a lecturer at UCSI. And then, of course, we are nothing without our dedicated trainers, amazing trainers. So we have four main trainers. The first one is Mr. Ivan Chan Kaichin. He was in University of Cambridge for his undergraduate. Now he's doing his masters at University of Bonn, and he has been in the IMO since 2015 and 2018 until 2018. So he's been in the IMO for 4 years. Okay, so he's a very big help, and he's very how do I say, very energetic with the trainings. Okay, so he's initiated lots of things for our training this year when he's made. He was a full trainer since last year, but this year we made lots of revamps in our system, and he's been making lots of it a reality. And then there's Mr. Yosi Song, of course. He is famous for being in the IMO for 7 years, the longest for any Malaysian. So he's been in the IMO since he was uh, in uh, in
12?
2014.
When he was
Yeah,
12, right?
12, I think. Yeah, 12. So ever since he was in primary school. So and then he won a gold medal in 2020. So he's been involved in lots of different Olympiads as well, the informatics,
Yeah.
and also linguistics. And he's won lots of medals from each of these Olympiads.
A very accomplished Olympian.
Yeah, in all all sorts of Olympiads.
In all sorts.
Very accomplished. Now he's a student at MIT. Yep. Just like Mr. Swahimi. Mr. Swahimi was a student at MIT as well. And then there's Mr. Lokzikin. Of course, I've met him in 2008 when we were training for the 2009 IMO, and he was with me in Germany for IMO 2009. So I've known him for a long time. Um, he's been to the IMO 4 times, and after that, he went to Stanford for his undergraduate, and now he's an IMO trainer. And because right now we are in the middle of a training session, so this morning I've just spoken to him. So yep, he's been involved with training even before I got back, even before I moved back to Malaysia. I think he's been involved with the training longer than I am. And then there's Mr. Jonathan Ramachandran. Again, he was a participant in IMO 2002, and after that, he did his degree in actuarial science in UKM, National University of Malaysia, and he worked for Schlumberger and lots of different works. And finally, now he's a freelance IMO trainer. So he's also one of the trainers in our team. So
Oh,
it's a small team. There's 8 of us, but yeah, we try to make everything work.
so the trainers are usually IMO alumni, and most of them went on to study mathematics at university, right?
Yeah, most of us studied maths at university. Of course, there are some who decided to choose something else, and we'll talk
Asians
about
are
that
used to
later
doing with
when
math.
we
Yeah.
look at the alumni.
Okay.
Okay, so about the IMO itself, so I would like to talk about what is it about. So lots of people think it's just a maths competition, but it's not. It's really the name suggests it. It's the International Mathematical Olympiad. It's like the Olympics for maths. So it's a very prestigious competition. So the IMO is the most prestigious world mathematics competition for high school students. It's open to students up to the age of 20, as long as they're not enrolled in an undergraduate program at a university. And it's the oldest science Olympiads. It was founded in 1959 in Romania. And I think physics came 8 years after that, and then chemistry came 1 year after that. So it started with mathematics, and then 8 years after that, you have the IPO, IPHO, and then you have the ICHO after that. And it was founded in 1959, and Malaysia only took part in the IMO starting in 1995. Okay, so it's relatively recent compared to any other countries. Okay, so to date, up till last year, the previous IMO, there are exactly 80 Malaysians who have represented the country at the IMO. So some have represented multiple times, some have represented once, like myself. But in total, there are 80. So the structure of IMO is each country can send up to 6 students. So some other science Olympiads, they have different structures. I think physics, you're allowed to send 5 students. I think so. I was involved with IPHO for a bit before I decided I want to do IMO. That was, I think that was IPHO was 5. Okay. So the eligibility, it's not open to everyone. The restriction here is that the student must be at most 20 years old on 1st of June of that year, and not enrolled in undergraduate study at university, so that you don't get any competitive edge over the other contestants. Okay, so it's a high school competition.
And the
Um,
contestants must be Malaysians, right? Must be a resident or citizen of Malaysia.
yeah, so to represent Malaysia, you have to be a citizen of Malaysia. So, but in general, in other countries, you might have people with dual citizenship, and there are lots of other complications. So some other countries would have their own rules. But for us, since Malaysia doesn't recognize dual citizenship, you have to be Malaysian, fully Malaysian, to be selected to represent Malaysia to the IMO. Okay. But the main IMO, the eligibility is just you're not more than 20 years old at on the 1st of June, and also not enrolled in undergraduate study. That's it. So that's what the IMO board says. But different countries have their own additional rules. Okay. And how do you get medals? Of course, it's the Olympics. Therefore, you expect medals. There are three different medals: gold, silver, bronze, just like any Olympics sports. And 50% of the participants will get a medal. Okay, so 50% will get a medal, and the other 50% will not get a medal. And among the top 50% of the participants, the ratio of the awards is 1 to 2 to 3 for gold to silver to bronze. Okay, and for students who did not get a medal, there might be you might get a different kind of award. This is called the honorable mention. Okay, so honorable mention is that if you'll get an honorable mention if you answered one question fully correct. Okay, it sounds simple, but it's not. There are six questions, and each question is worth 7 points. So if you get 7 points from one question, you automatically get an HM. Okay, and to date, up to last year, Malaysia has won a total of four gold medals, and proud to say that one of them is during my time as the team leader. 15 silver medals, 27 bronze medals, and 38 honorable mentions. Okay, so this is the cumulative performance of Malaysia so far.
So like compared to other countries, are Malaysia performing good? Is it considered as a good score?
Uh, okay, so I have a graph of it that denotes the performance of Malaysia later on in the slides, and also the scores of the team. Well, not scores, so relative. How do you say, relative position of the countries in the ASEAN region later on. So we'll look at that. So
All
it's
right.
nice to have a slide to refer to. Okay, so it seems easy. If you answer one full question, you get an HM. Well, it's not because the questions are quite tricky. So the IMO format is you have two papers over 2 days. So you have to sit for two papers, and since there are a total of six questions, you will try to answer three questions every day. Okay, and how long is each paper? So each paper is about 4.5 hours. It's quite long, so you are allocated about 1.5 hours for each question, but usually that's not enough. Um, and yeah, so each point is worth 7 points. Each question is worth 7 points. And the problems are kind of drawn from four broad topics. So they are algebra, combinatorics, geometry, and number theory. So all the things from university onwards, like calculus or analysis or linear algebra or abstract algebra or probability, they're not involved in the IMO questions. However, you can still use them to answer the paper. Okay, but the main idea is all of these questions are solvable. You can solve them using techniques, basic techniques,
So
basic techniques.
yeah, so even a primary school student with some knowledge of mathematics, even though he doesn't have knowledge about calculus or a real number analysis, he can still solve the problem, right?
Yeah, exactly. Provided that you work hard enough. So the IMO questions, they are more of a problem solving question rather than a theory type question. So even if you know the theory, it might not help you to answer the questions because you kind of have to struggle a bit when you do problems. You have to try this, try that, work with this, change the problem, or yeah, lots of different techniques. So
So,
it involves more than just knowing the theory.
so
Okay.
knowledge is like a necessary part of IMO, but not sufficient to to get a good score in
Yeah,
IMO.
exactly. Yeah, so you need to have that problem solving bone
Problem
in
solving
you.
skills. Yeah, okay.
Yeah, so that's what the training camps are for. We try to like instill this critical thinking, and problem solving, and viewing the problem in a different way, or changing the problem and try to make the problem work for you, all these sorts of things.
So it's much more than just maths.
Yeah, there's the maths aspect to it, but there's also the problem solving aspect to it.
Okay.
So when I was a student, a math student in university, you can kind of split the maths people into two different um, groups. One is the theory builder, and the other one is a problem solver. Okay, so well, even if you are very good at theory, then that doesn't mean that you can solve the problems, because problem solving is a different skill altogether. Okay, and of course, you're not allowed a calculator in the IMO. You are only allowed writing tools, a compass, and straight edge ruler. So no calculators. Well, it won't even help because there's not much numbers there. And also, you're not allowed protractors. Okay, the straight edge ruler is just to help you draw a straight line, not
So
as a measuring
IMO is not about calculating numbers. It's not about a computational competition. It's more about like mathematical intuition and reasoning, right?
Yeah, proving stuff.
Proving.
Yeah.
Okay.
Yep. So there are some calculating questions, but uh, they're not difficult calculating problems. Okay,
That
so they're
doesn't
not like,
require the use of calculators.
yeah, they're not big numbers per se. It's like count the numbers of this or count the number of that, and yeah, it is a counting question. Uh, I'll share the questions in a bit. I've chosen four questions from each topics, so you can kind of see what it looks like. Oh, here it is. So let's look at the sample questions. Sorry, let me just turn off my. Uh, okay, all right. So here's a sample question from algebra. So I've mentioned earlier that there are four broad topics in IMO. So algebra, combinatorics, geometry, and number theory. So I'm going to show some sample questions from each topic. Okay, and you can see that actually the things in the questions are not very new to a high school student or a pre-U student. Okay, so this is a question from algebra for algebra. This is problem 2 in IMO 2017 in Brazil. Um, remember that I've told you about the two papers. So each paper has three questions. So there's question 1, question 2, question 3 on the first paper, and question 4, question 5, question 6 on the second paper. So usually question 1 and 4 would be the easiest. Question 2 and 5 would be medium, and question 3 and 6 would be difficult. Okay, so that's kind of the rule of thumb when the team leaders select the questions for that IMO. So this is problem 2, so it's kind of medium-ish. And what does it say? Let R be the set of real numbers. So I hope the students know what real numbers are. They're just numbers. And determine all functions f from R to R such that for all real numbers x and y, you have fx fy plus fx plus y equals fxy. Okay, so this question is kind of straightforward. Okay, even if you've just learned about functions, you would know what the question wants because there's only one technical term in here, which is functions, and that is covered in Form 4 in a government school here. Okay, so the tricky bit of this problem is to isolate the f's. Okay, how do I make f the title of this equation? Okay, so that's the problem solving part because you know what functions are, you know what real numbers are. So there's not much new here. You just need to be clever with your substitution. What do you need to put for x? What do you need to put for y? What do you need to rearrange and do things? Okay, sometimes you have to break into cases if you want to study cases, but yeah, it's clear what the question wants. So students who hasn't even attended the training knows what the question wants. Okay, so I'm not going to spend time to explain how to do this question because it's quite long. This is P2, so it's medium. uh, it's not straightforward. A lot of critical thinking, a lot of problem solving things going on there. So let's just move on to the next one. Combinatorics. So combinatorics is about counting things, combining things, arranging things, all sorts of this discrete operation. This is P4 from the Netherlands in IMO 2011. It's a long question, kind of intimidating, but actually, in problem solving, the longer the question, the better it is because you are given more information and you have more information to work with. For example, this question is very short, but it is tricky. So this is very long, but it's actually quite easy. So let n be an integer. Well, students should know what an integer is. And we are given a balance and n weights of weight 2 to the power of 0, meaning 1, 2 to the power of 1, dot, 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 all the way to 2 to the power of n minus 1. So you have two weights, like two balance and n weights. And we have to place each of the n weights on the balance, one after another, in such a way that the right pan is never heavier than the left pan. Okay, so the left pan is always heavier. At each step, we choose one of the weights that has not been placed and place it on one of those pans. But all the time, keeping this the right weight, the right pan above the left pan. Okay, and determine the number of ways this can be done. Okay, so it's a combinatorics question because you have to count the number of ways you can arrange. Okay, which one you put, which of the weights you pick, and which pan you put it in. Okay, and there are lots of different ways to put it. You can put 2 0 first, and then well 2 0 well 2 2 2 1 first, and then 2 0, or you could put 2 2 first and 2 0, and so on and so forth. So you have to count the number of ways. All right. So again, this is a counting question. So you have to find a number. It's not a proving question, but the numbers are quite easy to work with. They're just 2 to the power of 0, 2 to the power of 1, dot, dot, dot. They're not weird numbers. Okay, so you don't need a calculator. Um, so maybe you can try this. This is a very nice question about combinatorics. And next, geometry. So this is problem 1 from IMO 2018 in Romania. This is the year where I became, this is the first year that I was the IMO team leader. So I still remember this question. And the question is ABC be an acute angle triangle. So lots of students, I think all students should know what an acute angle triangle is. With circumcircle gamma. So circumcircle is something new. So we explain what it is in the training camps. Okay. Circumcircle. Let D and E be points on the segments A, B, and AC, respectively, such that AD equals AE. So you have to place these points on the segments A, B, and AC. Okay. The perpendicular bisectors of the segment BD and CE intersect the small arcs AB and AC at points F and G. Prove that DE is parallel to FG. Again, these are all the things that, most of these things, as a high school student should know. They should know what is a perpendicular bisector. Okay, I still remember that in Form 2 or Form 3. And parallel is even earlier. So students should know what parallel means and what entails from it. So using these things, you need to prove DE is parallel to FG. And it seems like a school problem, but it's a bit more involved because you have to play around with the question a bit, draw diagrams, and see if you can find any relationship between points and lines and so on and so forth. So yeah, so it's all the things. So the bottom line is most of the things in the question are known by the students already. All right, these are
So
all high school
everyone
material.
can understand the question, but to solve it, you need some critical thinking.
Yeah,
So
exactly.
everyone can solve
So
it.
yeah, it's all done in school. You just need to sit down for 1.5 hours or four and a half hours and work this problem out. And finally, number theory, P4 from IMO 2019 in the United Kingdom. All find all pairs Kn of a positive integer such of positive integers such that this equation holds. Okay, so again, factorial is something that students should know. I think it's in Form 5. And all these products are something students should know as well. And well, you have to play around a bit, you have to factorize it more and see what happens. So it's a short question, but it can be a bit tricky. All right, so I just chose this question because it's a cute question and the solution is quite nice. And it's easier to explain to people what is factorial. Everyone knows factorial. Okay, so those are some sample questions, and we're going to look at previous participants for the IMO. Okay, so this is the oldest IMO photo that I can find. IMO 2007 in Hanoi, Vietnam. So you can see Mr. Lok Zikin, the one on the in the middle, holding the flag. So that's Mr. Lok Zikin, and now he's one of the trainers um, for the IMO
Mr.
team.
Suhaimi, Mr.
Yeah,
Suhaimi,
Mr. Swami is holding the Malaysia what do you call that, placard?
sign,
Yeah,
yeah, the sign, yeah, the card, yeah.
and behind him is Prof Salmi. Prof Salmi worked in UKM. He's just retired last year, and then Prof Asma is on Mrs. Swami's right. Okay.
So they were the previous committee of IMO Malaysia.
Yep. So they were previously. So the funny thing is, back then in pre 2009, all the committees are maths professors from university. But in recent year, we don't get any much involvement from university. So I've been trying to get that because we probably could benefit more if we get um, university lecturers or university professors to be involved with the training because it gives a bit of a competitive edge to the students. But yeah, in recent year we don't get as much involvement from university stuff.
So it
So
will
it
be best if, like, in the future, universities like USM, UPM can get their mathematics lecturers to work together for IMO Malaysia.
yeah, so that's my hope. And yeah, I really hope that would happen in the future. Yeah, I remember in pre 2009 you have Prof Jamal from USM, and then Prof Daud from UITM, Prof Abu, Prof Matrofa, Dr. Alino, all these big mathematics people in Malaysia, focusing, not focusing, but working, collaborating on the IMO. It's also a chance for the Malaysian mathematical community to kind of nurture mathematical talents in students and get students more interested in mathematics at university. Yeah, so I was originally how should I say, originally sponsored to do engineering by the government, but then after joining the IMO, I decided that maths is my real passion. So that's how it goes. You just inspire people to um, to do
So
maths.
IMO like change your life into the maths, into a maths
Yeah,
career.
so yeah, I was doing IB, prepared to do engineering, and yeah, it just changed.
Then IMO happened. Okay.
Yeah, IMO changed it. And then in 2008 in Madrid, so again, Mr. Luke Zikin there in the middle with the medal, the silver medal, first silver medal. for Malaysia, okay, in the IMO. And there's Mr. Tam Ying Hong on the left. So we're going to see a bit of more about him later when we talk about alumni and what they're doing now. And then there's this our team, myself in Bremen, Germany. So Mr. Soimi was the leader, and Mr. Luke Zikin in the middle, and myself there on the right. It's a very small team because of the H1N1 pandemic again. So the Malaysian government actually barred us from traveling. So we couldn't go to Germany because there was a travel ban on international competitions for students. But since myself and Mr. Lok Zikin are of age, we are adults, legally adults. We could go, so that's why it's a very small team. The others are younger than 18, I think, at the
So
time.
during that year, only two of you guys get to go for
Yeah,
IMO.
only two of us. And the interesting thing about this team is that 100% of this team is currently contributing to the Malaysia IMO committee now. So it's a very successful team, I guess, in that sense. Okay, so next, this is in Astana, Kazakhstan. So there's the twins there, Hao Siyu, Hao Siwei, and Mr. Tam Ying Hong again. So Mr. Tam Ying Hong was selected to go to Bremen last year, but he was, I think, was 15 at the time, so he couldn't travel. So now he's gone to Astana, and again, Mrs. Wahimi there. And Amsterdam, Netherlands, again, there's Mr. Tam Ying Hong and all the other teammates. Mar del Plata in Argentina, Mr. Tam Ying Hong is there again, and the twins, Hao Siyu and Hao Siwei. And this is in Colombia, first one in South America for Malaysia, since 1995 at least. This is in Santa Marta, Colombia. There's Mrs. Waimi again. And on the far left, that's Dr. Ikwan. Dr. Ikwan used to be involved with the IMO as well. He was studying maths, and now he is a philosopher. So he took a different path and became a philosopher. Um, so we're still trying to get him to be involved with the IMO training. um, and yeah, so sometimes you start with maths and you do something else, or you also have the opposite case. You do something else and then you end up with maths. Dr. Ikwan is the son of Prof. Asma, if you remember that one, the lady on the far right. And he was very into maths at an early age, did maths in university, and decided, uh, actually, no, I'll do philosophy instead. Okay, this is in Cape Town, South Africa. Again, this is the first time Yosi Song participated in the team. Um, and we got a gold medal here, two gold medals actually, from Anzo and Justin. So it's a very successful year in terms of gold medal. And then in 2015 in Chiang Mai, Thailand, there's Ivan, Mr. Ivan, who's one of the trainers on the far left, and Hanisa was on the right. So Hanisa joins the team for 3 years, joined the team for 3 years, and winning a bronze medal in her third year. So this is in Hong Kong. So Mr. Zafri is there on the far left. And we have Ivan in the middle, Zisong to next to him, and also Hanisa. And here is in Brazil, Rio, in 2017. So Hanisa on the far right won a bronze medal, and then we have Ivan there. Okay, and I think Zisong had to go because he's very busy. He had to go to the IOL, Linguistics Olympiad. So even though he got a medal, he had to go to the IOL to take part in that. So he had to leave early. So that's why there are only five of them. Okay, and there's Li Shan there. Li Shan just on the left, far left. He just got accepted to MIT, and he's involved with the training also now. He's part of the tutors, like a problem solving class where he leads some problem solving class. And then this is Romania, 2018, the first time I became team leader. I'm not in the picture. Okay, so there's Lishan on the left, Tristan next to him, and then Ivan and Zisong. And 2019, this is in Bath, so it was close to Oxford. I was just finishing my PhD, so I just had to take a bus to go to Bath. So I became a leader there as well in Bath. And this is the final IMO that we get to travel, that they get to travel. Okay, because after that, all the IMOs are online. So in 2020, it's online, and last year as well, it was online. And last year it was fully online. We didn't even get to meet each other. So last year there were no photos of us. And last year, in 2020, Mr. Zafri was a deputy. Okay, so this is a team ranking for Malaysia ever since we joined in 1995. So you can see there's an upward trend at the beginning, and it kind of oscillates around a bit towards the end. But this is normal, okay, because you cannot predict what the questions are like. Some years the questions are difficult. Some years the questions are more manageable, and also you can't predict what the other countries are faring. Okay, so how they are doing with their training and so on and so forth. And we've so far we won 4 gold medals, 15 silver medals, 27 bronze medals, and 38 honorable mentions. So you can find this graph in the official IMO website. So you can find all the graphs of all the countries there. Right, so this is the ranking relative to ASEAN countries, so our neighbors. So we saw in the graph that in the recent years, we kind of go down a bit and then up and then down a bit. So this is the actual numbers for our ranking. So in 2018, we came 48. 2019, our our ranking went down to 70 and then went back up and in 2020 and back down in 41. So it kind of oscillates quite widely. So this is perfectly normal. So um, relative to our neighbors, in 2021, sadly, we came last relative to our neighbors. So Vietnam came first, and then Singapore, Thailand, the Philippines, and Indonesia. But if you notice, other countries also fluctuate quite widely. Like Indonesia started with 10, 14, 32, 33. So it goes up and down, all right? And also Singapore. So there are 8, 8, 16, 15. So
So like throughout the years, Malaysia still like it's like the middle between Asian. Like we are like performing better than Myanmar, but sometimes the Singapore or Vietnam can overtake us. But we are in the middle of Asian countries, right?
yeah, middle to close to the end. But yeah, it's kind of difficult to predict this kind of things. And there are lots of other factors that come
A lot
into
of
it.
factors I see.
Yeah, and Myanmar just recently joined the IMO. I think they joined in 2016, so they're still trying to uh, gauge and get a hold of it. So and even last year they didn't participate.
How do you think we can like increase the country's performance? Like, is it we need more funding or more training or just more awareness? Have a bigger pool of participants.
I think the main issue, well, not issue, but thing that we can improve is our education system, okay, and also awareness. we do have a large pool of talented students. So this year for our training, we selected 100 students. And we are currently at our third stage. So previously we had 300, and then now we have 100. So it's a huge pool. Um, it's just we don't have this strong basic. Okay, so in some countries like Vietnam and Singapore, they have these specialized schools where the students are who are interested in sciences and maths. They would go to these schools and be trained by very experienced teachers, maths teachers. Okay, and these maths teachers are not just they did proper maths, so they know what it is, what it's.
Mathematics, they study mathematics in university compared to teachers in Malaysia. They just go to Institute Pendidikan Guru to get basic maths education. So is it like Singapore, Vietnam, those maths teachers actually go for university to study maths? Do you mean
Yeah,
that?
exactly. Yeah,
I see.
exactly. And I have friends who in when I was a student in university, when we graduated, some of my friends who did maths, they these are they are graduates of Imperial College London, and they decided to be school teachers at specialized schools. Okay,
In,
so
in
they like to disseminate the knowledge of mathematics to young people, and these young people are very interested in mathematics as well. So it's a win-win for them, and that's why they get really good talents out of them.
so
And
you like in Singapore, like this type of countries, like your friend.
my friends in the UK.
UK. So UK also has this type of specialized schools and
Yeah,
teachers.
I think lots of European countries do have them. Like some of my friends in Oxford, they went to specialized schools in Poland, in the Netherlands, and so on and so forth. So they know what they want to do, and they are trained from a young age to do it. So
What about in like Malaysia? We have Permata Pintar, I mean Genius Pintar and Insan and all those things.
yeah,
What do you think
so
about it?
we do hope to get more participants from there, because we don't get that many participants from those schools, sadly.
Okay.
So hopefully that this video, someone will see this video and, and send their gifted students to join IMONST.
Okay.
And another thing is about our training, of course. In other countries, for example, in Germany or in Poland, the trainings are done by university students. These university students are ex-Olympians. Well, then they not necessarily went to the IMO, but they were involved with the training and the early stages, that they are confident enough to train the younger students. Okay, so Mr. Ivan showed me a program, I think in Romania or somewhere, I can't remember, or Germany, something like that, where the university students actually train the school students for the IMO. So they have a strong IMO, not IMO per se, but Olympiad community in universities that could contribute continuously to the younger students. So I just view this as and it's just amazing. It's just the system is amazing.
So like for a country to be mature in the Olympiad scene, the local universities, the local public universities in the country will have to work closely with the education stakeholders like the students and the government. So
Yep.
that will make that will makes a top performing country in the Olympiads.
Yes. So not just in the Olympiad program, but any other program, university should work closely with schools to kind of expose these things to the students early on. And another thing is our curriculum in maths is quite computationally based. Okay, so in comparison with other Olympiads, for example, physics, when I was in IPHO training camps, I remember Miss Chin, Madam Chin. So she was STPM. She was an STPM teacher, and she was involved with the training. So I just realized that our curriculum, the IMO curriculum, is quite far from the STPM curriculum. But for example, because STPM teachers can't really train the IMO material, whereas STPM physics teachers can train IPHO students. So the problem with maths IMO curriculum is it's quite far from our school curriculum. It's not far really because it's just the same things, but the way of thinking and the proving aspect of it was just brushed under the rug in our school. So we don't really talk about those. Even I still remember when I was in Form 4, we had to learn um, penakulan mantik in mathematics modern, this mathematical reasoning. So it was put towards the end of the chapter, towards the end of the, not chapter, towards the end of the syllabus, which is kind of defeats the purpose of mathematical reasoning because mathematical reasoning should be the first thing
Yeah, the
to
first, the
teach.
basic. Yeah.
Yeah. So
Do you think the country should put more effort and put more focus on this type of mathematical reasoning into the core curriculum for the public school students, like what we do
um,
for
at
I4?
an appropriate stage, yes. So I don't think it belongs in the um, the basic maths course because not everyone would go down that line. But probably in additional maths, it would help because additional maths is more about thinking mathematically, proving things, rather than just calculating. Because you already have the first course in maths to do all the calculating. So even in STPM and matriculasi, yeah, if you can't um, introduce it during SPM, probably SPM, matriculasi, that would be an ideal place as well because the students who chose to do maths, they know that they actually want to do maths or related subjects in university. So they need to know these basics. Okay, of course, granted, we also teach um, mathematical reasoning in the first year at university, but it would be good to have some kind of exposure um, to it early on.
Yeah, that would be great. We will send a copy of this video to someone in the Ministry of Education and see if they can get
Okay,
some inspiration.
that
Mm.
would be amazing because I have lots of things to say about the best education. Okay, so okay, that's it.
Yeah,
So
so
yeah,
moving on.
relative to our
Yeah,
neighbors, we're kind of lagging behind a bit. But yeah, there are lots of factors to it. It's the uncertainty in the papers. Yeah, it's just lots of things. Okay, so we've seen pictures from previous IMOs. Where are the next IMOs? Okay, so this year, IMO 2022, it will be in Oslo, Norway. Okay, nice seaside city. Um, but hopefully, we get to travel there this year. And hopefully, I don't know, maybe there are other travel restrictions. Um, uh, Pertaining to COVID. So we don't know at this stage. It's still too early. It's January. So hopefully it's in Norway. And we are currently going through the selection. So we have narrowed the participants down to 100 now. So we just had the second training camp yesterday. Um, and we have lots of training camps. And next year, so if you're still interested and you're still eligible, so hopefully next year it'll be in Japan, Chiba. It's just a town next to Tokyo, so will be interesting. And in 2014 in Kiev, Ukraine. So I like Kiev. Kiev is a very nice city. And then in Melbourne, Australia in 2025. Okay,
so
so if you
if
look at the
any
logo of, sorry.
so if any interested students who would like to join IMONS this year, they will be like sponsored by the government to travel to Japan, Ukraine, or Australia
Yeah,
when they get
exactly.
into. Yeah.
Exactly. Yeah. So if you want to go to Japan, go join IMONS this year. Kiev next year, and it's all sponsored by the government. So you only have to pay the initial fee for us to raise our
30
funds
ringgit?
because
Yeah, is it like 30 ringgit registration fee at the start?
yes,
Yeah.
30
And
ringgit because we have to set up the website and the website costs 20,000 ringgits.
20, oh wow. But
Yeah,
if
and
there's like, people with financial struggles, they can still request a fee waiver, right?
yes, so we have to get a letter from the school saying that you are from a lower income background or yeah, something. Just a justification. And the logo is interesting, IMO, because I don't know what the eyes are for. It's just eyes for the circles. The M is the mountains, so Oslo is surrounded by mountains, and the O this is an homage to Sophus Lee. Sophus Lee is a Norwegian mathematics, and he invented Lie algebra and Lie groups. So this is an example of a Lie group. I think it's E8, if I'm not mistaken. So there is a strong mathematical history in Norway as well. Apart from the Nobel Peace Prize.
Do you see Malaysia next on the list on the future? In 2000,
So when I was in 2009, when I was in Germany, we had a sit down with Mr. Swami, with Zikin, and we were thinking, oh, we can do IMO, probably can host into 2020. That's not a problem. It's 10 years from now. But 2020 has passed and we didn't. So it requires a lot of logistics. For example, you have to find a place to accommodate all the students from everywhere, get a bus, get a university. It's because usually the students stay in a university, so we have to find a university for the students to stay in. And it's not just that; it's the background of it, the juries, the judges, the problem committee, and all these things. We need to import lots of mathematical talents from abroad because we don't have enough experienced mathematics people. Well, IMO experienced mathematics people in the country, so we probably have to import them from other countries. So it's a big logistics. So, for example, in the UK, they have a big um mathematical IMO community. Okay, even the non-related, the ones that are not related to IMO, they still could be the jury. So, for example, Jeff Smith, the president, the chairman of the IMO board, is from University of Bath. So there's already the big guy there, and then they just have to call these PhD students, professors from universities across the UK that has been involved with the IMO to Bath, and yeah, they can manage everything. So
so
the logistics there is not too difficult. If we do it here, we have to find all the people, but we don't have enough manpower in Malaysia alone, so we have to import all these people from outside. So that's a big thing. So
so
it
by
could
the
be
time
difficult.
Malaysia organizes IMO in the future, that will be the time where the mathematical community in Malaysia has finally matured and be able to organize such an event.
Exactly. So I don't know, probably in the next 20, 30 years, it's uh, it's a big thing. So it's just like the
It will be
Olympics,
a
where
milestone for the mathematical community in Malaysia, would it?
yeah, and it's just like the Olympics where you have to. The Olympics is held once every 4 years because the preparation is just insane. Okay, it's the same thing, but IMO is of a much smaller scale, and the participants are just high school students, so it's not as big. So that's why they can do IMO every year. Okay, so why do you have to join IMO? So this is a big question. The main objective of the IMO program is to expose you to real mathematics beyond school level. So as I mentioned earlier, and I've shown you the sample questions, the questions are they just use the things that are introduced in school. Okay, there's nothing fancy. There's no topology. There's no group theory. There's no Hilbert spaces or anything like that. So it's just basic mathematics, but the technique and the thinking of it uh, is a bit beyond school level. So it exposes you on how to think like a mathematician, how to see what mathematics is like, how real mathematics is like. So in school, you just calculate stuff with your calculator, but me as a mathematician, I haven't touched a calculator in probably 12 years. So yeah, it's a different face of mathematics. It's closer to the real mathematics. And why IMO? There are lots of other competitions out there. Lots of mathematics competition out there. But why IMO in particular? Well, IMO is a genuine not-for-profit Olympiad on real mathematics. Okay, so it is not for profit. You don't have to pay for it at the international level. You just go and participate in it, and they take you for excursions. They give you food and everything. So all is sorted. No need
So
to
the
pay
like
except for the
the
first.
local host country will be the one covering the expenses.
Yeah, so local host country and also the IMO board, they have lots of funds from big companies. So they have lots of money. uh, so yeah, you just go there, do the exam. They take you for trips and go home. So it's kind of nice. You just have to pay 30 ringgit at the start. For IMONS, and that is not for our profit. It's for setting up the website and so on and so forth. And it's a genuine competition. So some competitions they create the competition. They and as a how do I say this? As a reward of participating in the competition, they give you a certificate. Okay, so it's not it's not the same here. So you have to work for it to get the certificate. So it's a genuine thing, all right. And also, it contains real mathematics, not just some um, calculating or mental arithmetic or so on and so forth. So it's actual real mathematics. It is being managed by actual mathematicians. So the IMO board, the chairman or the president is Dr. Jeff Smith, and he's a real mathematician at the University of Bath. He works in, I think, in group theory. So lots of the people up there are actual mathematicians. So um, you can guarantee the genuineness of the mathematics. Okay, so it is actual mathematics, not just calculating or whatever. Okay, and there's no payment or fees required except for the start. And it is a genuine one, so you don't have to worry about money or anything. And also, IMO has a long list of alumni who are big figures in mathematical worlds. So most, well, not probably lots, probably not most, but lots of the IMO alumni went on to study maths, and some went on to research in math, and they get lots of they do lots of discoveries, and they are now big figures in the mathematical world. And there are actually 16 Fields medalists from the IMO Mathematical IMO alumni. So if you are not sure what is a Fields medalist, so think of Nobel Prize. So what are the prizes in Nobel Prize? So there's peace, literature, physics, economics, and biomedicine. Is there anything else? Chemistry?
I think that's it. Yeah, that's it.
Yeah, but there's no maths. Okay, so the rumor is Alfred Nobel hates mathematicians because his wife cheated on him with one. So that was the rumor. I don't know whether it's true or not. So there are no Nobel Prize for maths. Instead, we have the Fields Medals. So Fields Medals is the highest recognition in mathematics. So in the mathematical world, 16 of the Fields medalists were IMO alumni. So they went on to do really big things in mathematics. And apart from that, IMO is also recognized by top mathematics departments, universities, institutions in the world. So it helps you with your university application. So, for example, Yozi Song went to MIT. MIT was very impressed with his IMO performance, get accepted. Also, Li Shen in MIT as well. Mr. Swami was in MIT. And yeah, there's just lots of them. And then Ivan went to Cambridge. Okay. And of course, there are lots of other big universities like Mr. Zekin went to Stanford, right? So these are big universities. So you can see that the alumni went on to world-renowned universities, which recognized their IMO experience. Okay, so these are, if you go to Wikipedia, you can find all the IMO alumni with maths awards. So there's Fields Medals, Wolf Prize, EMS Prize, Clay Award. Okay, but these are the notable international IMO alumni. So these are from outside Malaysia, and these are the big ones that I know of. I've been doing this research and try to find ex IMO people and find out what they're doing. So they not just do maths in the future once they graduate. Once they did the IMO, they do all sorts of things. So the first one, Hungarian Lajlo Miro from IMO 68. He's a psychologist, which is very different from maths. But he did really well in the IMO. But he decided, no, I'm going to be doing something else. And in 73, Mongolia, you have Men Sai Khani and Khai Skan, and he was a prime minister of Mongolia. So he went to do IMO, and he ended up being a prime minister of Mongolia. All right, so that's interesting. United Kingdom, David Walker in 75. Now he's a bishop of Manchester. So he's a big guy in Manchester now. Johan Hastad, computer scientist. Alan John Dix, artificial intelligence and ethics. There's a computational biologist. And Soviet Union, Grigory Perelman. So probably you've heard of him. He's a very famous guy. He was in IMO 1982, and he solved the Poincare conjecture, one of the millennium problems. And how did he solve that? He used Ricci flow. So my claim to fame is my PhD thesis is about Ricci flow. So Gregory Perelman is kind of like a deity to me. So he's a big guy. And the interesting thing about him is he was awarded Fields Medal for the for proving the Poincare conjecture, but he declined it. So he declined the Fields Medal along with $1 million prize. So he's the only guy in history that has ever declined a Fields Medal. So that's
So
amazing.
why would you decline such an honor?
Yeah, it's such a big honor, so he just declined it.
Yeah, why would he do that?
Why would he do that? He said, so the Ricci flow was invented by Richard Hamilton, and
See,
Richard Hamilton said probably I can use this to prove the Poincare conjecture, but he couldn't. And Gregory Perelman, who was the one that actually did it. So and then when Fields Medal was awarded to him for proving the Poincare conjecture, he said, "Well, it's Richard Hamilton's because it was his idea."
yeah, what a gentleman.
Yeah. So and now yeah, he was offered lots of different jobs in different universities, but he just declined all of them, and he just hides away in Russia now, collecting mushrooms. And then there's David Chalmers, another weird guy. Same year, now he's a philosopher. He works in philosophy of mind and consciousness and all these weird things. I can't understand what he was writing. And John Overdeck, he was in IMO 86, and he didn't do maths. He co-founded an investment company called Two Sigma Investments, and probably you've never heard of it, but the investment world, it's a really big company in the US. So it's worth about 60 billion USD now. Yeah. So Joan Overdeck, he didn't do maths, but he did something else, and he's a rich guy now. Terry Tao, again, probably you've heard of him. He's very uh, clever guy, very genius guy. Um, we went to the IMO 86, 87, 88, and I think the first one was when he was 12 or something. And he's also awarded the Fields Medal. Oh, I forgot to mention another thing about Gregory Perelman, the really impressive but weird guy. He went to the IMO only once in '82, but in that year he won perfect score. So yeah, he won perfect
It's
score in the first
foreshadowing
time.
of a Fields medalist. It's a
Yeah,
foreshadowing.
yeah, first time, and he got a perfect score, and that's it. More okay, more recent ones. Nico Sordan from Romania, mayor of Bucharest, mayor of the capital city. Eric K. Websick, 2 years in the IMO. He's not the co-founder of DE Shaw, but a managing director. So DE Shaw is another big company. There's a cryptographer, theoretical physicist, and then there's a lady called Maria Mirzakhani from Iran. Um, won Went to the IMO 94, 95, won Fields Medal as well, and Clay Award. But sadly, she passed away at the age of 40, very young, very sad. And then there's Nikolai Durov, Russia. So I'm sure you use his stuff even though you don't know him. So he went to the IMO in 96 to 98. He was a co-founder of VK, a social networking thing, and Telegram. So you use Telegram all the time. So this is the founder of Telegram. He founded Telegram with his brother, can't remember what's his name. And Taiwan, there's a biostatistician, so not necessarily mathematics, economist, and there's also a professional poker player, Valentin Vorniku, went to IMO twice. And the most recent amazing one is Peter Schulze from Germany. Went to IMO 4 times, and I think he's the youngest Fields medalist. So he won Fields medals a couple of years ago, and he's at University of Bonn now, where Mr. Ivan Chan is. So probably Ivan Chan will win us a Fields medal in the future. I don't know. Okay, so these are the international IMO alumni. How about local ones? Okay, so local ones are equally as impressive. Dr. Darren Ong, IMO 2002, 2003, 2004. He's a mathematician now at Xiamen University. He used to be involved with the training for a while before I returned home, but now he just wants to focus on his research. He does aperiodic tiling um, in Xiamen University. So, classic mathematician example. Another one, Amir Fazil, in 2008 and 2009. I met him at College Marabanting while I was a student. Um, he's an engineer now at Petronas, so you can be an engineer if you join an IMO. Faizu Badli went to Imperial College with me a year after I enrolled in Imperial College, and he's a financial analyst at PNB now. Yu Changyang, 2001, 2003, is a medical doctor, so very different career path there. Dr. Iqwan Azlan, IMO 2001, 2002, is a philosopher now, just graduated with a PhD. Tam Ming Hong, IMO 2008, 10, 11, 12, is a research fellow somewhere in New York City. So he graduated from Stanford, and then he did his PhD at Stony Brook, and then he works as a researcher in biology, bio something about genetics,
I see.
biogenetics or something like that.
So like
But
Dr.
it's related to maths. Sorry.
So alumni of IMO doesn't really have to be mathematicians. Like we have journalists, philosophers, psychologists, and even prime ministers. So it's like
Yeah, you could do anything basically,
IMO is like
because
preparing people to solve real world problems. Is it like
yeah,
how?
because some of the arguments are because IMO mathematics is very different to university mathematics. Like I said earlier, university mathematics is divided into two parts: the problem solving part and also the theory building part. So probably some people dislike the theory building part and then they decided to do something else. So for me, I like the theory part. So I'm quite bad at problem solving, but theory part I just like. So yeah, it just prepares you for all sorts of career. It's just the mathematical thinking is just it just
So
opens
like
up
like students
paths.
who students who don't want to be a mathematician, they should also join IMONS because of the experience that the Olympiad experience give them in the
Exactly,
future.
it's
I see.
the friendships that you make, the connection that you make, the social interaction, the communication with other people, the social aspects of it. I guess when you talk to other people, other mathematicians, you tend to be the discussion tends to be pedantic and very nitpicky. So it kind of builds you up as a person, builds your worldview. Okay. And then there's Shazril, who went to IMO twice as well, financial analyst at PNB. Jasmine Yao went to IMO in 2004, now a journalist. Okay, so very different thing. Okay, but why IMO? All right, so we've seen the alumni. Lots of them, they don't do maths, they do other stuff. Uh, what do they get out of this IMO? Well, students do not merely learn Olympiad tricks. So problem solving, of course, there are tricks, okay, to help you think about how to solve a problem. So, but you don't merely learn Olympiad tricks. You don't learn about these problem solving tricks. You also learn about real mathematics and logic. So you learn about how to write a proof, how to write a convincing argument, and then you also learn new mathematics. For example, in the training last week and this week, Zisong was presenting about probability, and I'm not sure whether it's advanced probability with measure theoretic components or something like that, but it's something, it's real mathematics. So it's advanced stuff that you don't learn in school. So you get to see what's in store for you if you study maths in university. Okay. When I was in undergrad, I remember some of my friends who actually trained in Olympiad camps, but in their own countries. We were in the maths program, and some of the students were not in the Olympiad program or has not been involved. And when they enrolled in the undergraduate program, they decided that they don't like it. Why? Because it's not the same as what they expected in school, where you have calculations, you have um, formulas, you have memorizing, but in university, you have to do proofs and all these things. So, yeah, some of these students, they don't expect maths to be like that. Okay. So if you join the IMO, you can kind of see what to expect. You know what real maths is about. Okay, so when you enroll in a mathematics program, you know what you are signing up for. Okay, because out of lots of the different majors, out of lots of the different courses, I guess maths is probably it could be surprising to some people because the school maths and university maths are very different. Like I said earlier, our curriculum is very different to university maths. So yeah, it's good to have a bit of an exposure beforehand. Okay, real mathematics do not involve rote learning, memorization, routine questions, and quick calculations. So real mathematics are not like this. So you don't memorize formulas, you don't learn techniques, you don't learn steps, you don't do routine questions, repeat the same questions over and over again, or quick calculations like mental arithmetic or whatever. You don't do that at all in real maths. Okay, it requires understanding of concepts and good communication, because when you want to write proofs, when you want to write stuff out, you have to be a good communicator. Okay, so you have to write it that you can convince the reader that you know what you're doing. All right, so proving is like that. You have to convince the reader that you are correct. All right,
So it's
and
like
I
different
guess
from school
Sorry.
mathematics. So it's different from school mathematics in the sense that the school mathematics keep telling you to, like giving you a predictable problem that you just need to apply a formula, and every time for like from 1 from 5, you just need to do what the textbook teaches you, and even any deviation from textbook, you wouldn't be expected, like given a score in the national curriculum. So like, do you
Exactly.
think like IMO is like fill in the gap of mathematics, the mathematical experience for the high school students?
Yeah, exactly. So, for example, the quadratic formula in school, I think it was in Form 4 at maths. Uh, you don't really know where it comes from. In school, they don't really teach you where it comes from. It's just a formula. And the discriminant is this b squared minus 4ac. Where it comes from? Well, just use it. Okay? So, in university, you get to understand why you use this to determine how many roots are there in a quadratic equation, and why the quadratic formula works to find the roots of a quadratic equation, and so on and so forth. So it's kind of this, yeah, you fill in the gaps of what you've learned in school. You just pick this formula, learn it, accept it. But in university, you have to keep learning where these things come from. Okay, and good understanding of concepts, like I said, and also good communication. So probably that's why Jasmine went to be a journalist. Good communication is required there. And yes, this thing from maths is very rewarding, not in prizes because it's very hard, but in skills. So for me, I value my experience in the IMO a lot because it shapes who I am now. Okay, so it's just uh, a personal development. Okay, um, mathematics is the why mathematics. Mathematics is the queen of sciences. So previously I said YMO, but now I said why mathematics. Mathematics is queen of sciences. You use maths everywhere, even though you don't see it. It is both challenging and rewarding. It is hard. It's challenging. Lots of understanding, lots of thinking, lots of logical deductions, and so on and so forth. But it's rewarding. Okay, it sharpens quantitative, qualitative, and reasoning skills. So because you deal with lots of quantities, of course, it sharpens your quantitative skills, qualitative as well, and also reasoning skills. So growing up doing maths, like not growing up, but ever since I did maths in university, 10 years in university, it shapes me to who I am now. My reasoning skills is very. I think my reasoning skills is quite systematic. So whenever I read something, I have to question it. Whenever and I would ask, "Where's the proof? Where's how do you get this data from? Where's how do you get this? How do you get that? Where's the reference? All these things." So you start to develop that kind of thinking. Okay, so when I
Even
talk with
outside
people,
of mathematics, like you can
yeah,
apply this
even
kind of
outside
thinking.
of mathematics, when I read the news, I would question everything. I would ask for proofs. I would ask for data. I would ask for all sorts of stuff. For example, for anti-vaccines, when you talk to them, you need to, okay, where's your proof? Where's your proof that this thing works? Where's your claim? What supports your claim, and so on and so forth. So it comes into play. It just shapes your personality. Some people say I'm a pedantic, but hey, being pedantic is nicer if you are correct. And develops problem solving skills. Of course, if you have all of these stuff, then you get you develop the problem solving skills. And of course, there are lots of mathematically driven job market out there. So now, actuarial science, economics, engineering, computer science, and the big ones, the big sexy jobs at the moment: data science, financial analysis, artificial intelligence, machine learning. Okay, so these are the big sexy jobs, and all of them requires maths. All right.
So like some parents out there, they're worried about sending their children to maths, to study maths. That in they're afraid that if my children become mathematicians in the future, there's no job market out there. Like there's no positions for teaching mathematics in universities. At the end, you just become a teacher of mathematics in public schools. But In this case, it's no, it's not really in. It's totally opposite. Like they will work on the forefront of all these big industries out there because of mathematics.
Yes.
I see.
So it kind of depends on the environment as well. So when I was doing maths in university undergrad, lots of people say, "Oh, that's a really good degree because you can do anything." And then I do my PhD. Some of my friends went on to do artificial intelligence and machine learning and all sorts of things, even though they do PhD in numerical analysis or functional analysis, all these things. Okay. Uh, but when I moved back to Malaysia, it's kind of the opposite. So parents are very afraid of sending their kids to do maths because they just think it's to be a teacher. Okay. And even when I talk to my students, they are worried about what they're going to uh, work as once they graduate. And I am one of the industrial training advisors for my students, even though I don't have any industrial training background, which is a strange appointment. Anyway, so most of my students, when they apply for industrial training, they always complain that the companies don't want them because they are doing maths. They want more specialized degrees like engineering or computer science or even accounting. But yeah, if you develop your quantitative, qualitative, and reasoning skills, you could do anything basically. It's the environment that kind of um, uh, disseminates this thinking. You do such a uh, vague degree in maths. What can you do? Well, you can do lots of things. So our country at the moment, we value vocational degrees. For example, when I was a student, when I was in high school, all of my teachers asked me, "What do you want to be?" And I don't know. And then they said you should do engineering or medicine because you got get good grades. So these are the big degrees in Malaysia: engineering or medicine or actuarial science if you like maths. Okay, so we don't really view other degrees as good degrees. Okay, so in Malaysia the mindset is a bit different. We value these vocational, very specific degrees, and we view as going to university. We view going to university as how do I say, as a means to get a job rather than developing your skills. Okay, so there's this different mindset in not just Malaysia, I guess, in Asian countries where if you are a doctor, if you are studying if you're clever in school, you should be a doctor. So this is, I think, an Asian country specific thing. India, China, Singapore, or Malaysia. Yeah. So it's not just restricted to Malaysia. So it's just this mindset of people, I guess. They don't really see what maths is.
So, but in reality, maths still has a lot of job opportunities out there.
Yeah, so but you can't be well, probably you can't be a doctor with a maths degree, of course, because you don't learn all those things. But there are still other stuff.
But you can be the prime minister of Mongolia.
Yeah, you could. I guess he has very good reasoning skills and very annoying technicality, probably. Um, yeah, it's just the way it is. Maths is, and another thing that I think is the major thing is we are not a country that develops technology. We are a country that consumes technology. So when you want to develop this technology, when you want to develop artificial intelligence or machine learning, you need maths. You can't run away with maths. Okay, so if you need to develop these, you need maths. But if you just want to consume it, you don't need maths. So this is, I think, in Malaysia, it's us. It's because we are not developing stuff. We are just consuming stuff. Okay, so yep, that's a bit of a tangent. Okay, so what to expect? A lot of hard work if you join the IMO. Learning real math is not an easy task. Yeah, it's not really easy. It takes a lot of patience. but they can be rewarding and satisfying. And also, I can imagine school students, you have to juggle school with maths. But when I was a student, when I was joining the IMO, I view maths as a hobby rather than um, a task. Okay, so I guess that makes it easier for me. It's a hobby for me. I enjoy it, and I don't have any. I don't do sports, or I don't play games or anything. So maths is the thing that makes me happy. So that's why it's a bit easy for me to juggle IB, my international baccalaureate, and maths, because it's something that I do to um, take the stress away. That's for me anyway. So we get lots of parents who are interested in sending their kids to do IMO, but the kids they don't want to do it. So it's up to them. You can't force them. Probably they have too much time, too much things to do and very little time. So that's why they don't want to do it. So yeah, you just ask your kid if you don't if they want to do it, and if they don't want to, then it's fine. You don't. It's not something that can be forced upon, because it's not an easy task. You can't force someone to do a difficult task that they don't like. You need to have the desire to learn new things and an inquisitive, questioning, sensitive mind. Like I said, I have a very sensitive, questioning mind. I question a lot of things. I read the news, and recently there was a news about some member of parliament saying there are 400 PhD a year in UPM, and he was kind of shocked and worried, and says that everything's going to the dogs. But for me, I've experienced with I'm experienced with university and stuff, so I get to think rationally. But other universities are like that as well. So what is the problem? For example, when I was doing my PhD, 10 people in my department alone graduated at the same time. So if I put together all of the departments, probably came to the same number. So yeah, I'm just sensitive like that. So whenever I read news, I just question everything. So people need to do maths to write news. And a lot of reading, practice, and self learning. Of course, reading is important. You can't expect the teachers to tell you everything. Practice, lots of practice. Solving problem is not something that is innate. You need to practice it. You need to keep doing problems to get used to it. Okay, self-learning, of course. There's only so much that we can teach with our own day jobs and your school, so you need to kind of read and pick up things. Okay, so lots of reading, practice, and self-learning. There's so much that the trainers can provide. The rest is up to your own effort. So it is a lot of work, but it will be worth it. What are the goals? So yeah, so IMO is just, it's not the end goal. So IMO is probably the end goal for some students, but they don't see the other things. Okay, so they get really upset when they don't get selected to the IMO. But throughout the camps, you learn lots of things. Okay, so the IMO committee wants to develop these things in school children. So train students to perform mathematical thinking logically, creatively, and rigorously. Okay, so it's not just calculating, it's about reasoning. So if this happens, then this happens. Okay, even lots of adults have that problem with logical implication. If A, then B. So, and then they would argue, what if B, then A? No, I'm saying A, if A, then B. So they can't even think about that. So we need to develop this kind of thinking amongst students. Okay, train students write correct mathematical proofs and communicate them effectively. So it's not just about proving things; it's to write them down and present your work to other readers so that the readers can understand what you're trying to do. Okay, so this is very important when you do homeworks and tests. Okay, I get lots of homeworks from students and tests from students where they just write here and then they go arrow somewhere else, no implications at all. And then they said, okay, then it is true. Uh, this just makes me annoyed because I don't understand what you're trying to do. Um, so, in order to convince people, you need to write proofs properly. write things properly. Like, if this happens, then this happened, but this happens, then blah blah blah. So yeah, it's an essay. So people say maths is not an essay, not a writing subject, but it is actually. So, and you have to communicate all these ideas effectively. And number three, my big hope, my big dream is to disseminate the culture of mathematical problem solving in Malaysian schools and universities. Because in schools, you don't get to see this. It's quite sad. I'm not sure about other schools, but when I was in school, I didn't know about the IMO or the OMK at all until I went to do my international baccalaureate when I was 18. And that was kind of too late. I only get to go to the IMO once. I wish I had more experience early on. So this is what I hope we can achieve in the future. Disseminate the culture of mathematical problem solving in schools. So we are too focused on exams. We are too focused on getting it right on the exams, but there's no mathematical circles in schools or in pre-U in institutions or universities even. So it's just like our schools are churning out people with certificates rather than this appreciation of knowledge. So it's kind of yeah, I really want to see that. Even in university, when I teach students, they pass a course last year, and I teach the students. I said, "This is something that you have seen in last year, and also this is what we're going to use." And they would complain because they said that course is finished. Why do we have to know all these things? Okay, that is kind of sad because there's no appreciation there, and yeah, I hope that I can see this in universities. Or schools to expose school prep students to real maths. Again, this is self-explanatory. We don't our universe our school and pre-U maths like matriculacy and STPM, they're very different from real maths. Okay, so probably the students don't like it because it's too routine, too much calculation, too I don't
It's
know. I don't
not
know what
about
else.
analytical reasoning. It's just like computational mathematics without any explanation of any kind. That they don't
Yeah.
understand the fullest form. Yeah,
Mhm. So I can see that some of the textbook topics they've put in applied maths like taxing and I don't know all these use all these consumer maths, but those that just does the opposite. It just puts maths into further away from real mathematics. It's a
like
good
people
topic.
people
Um,
wouldn't like appreciate it more. Like it's not as beautiful as number theory, or like geometry.
Yeah, exactly. It's good to expose these students to filing their tax, how to file their tax, how to calculate interest, and so on and so forth. But probably not in a maths course, or if they want, they probably can put it as a subchapter of some of the topics. For example, interest. I put this in sequences and series. Okay, so probably at the end, this is an application. Okay, so it's a good idea, but it's not real maths really. Okay. And finally, to nurture an intellectual community among students and teachers alike. So, usually, this Olympiad community, the students and the teachers, like I said, it's a circle where you discuss things, you talk about things, you um, appreciate maths. Okay, some schools there's no appreciation, there's no community, and teachers they don't really see this as well. Probably they are not interested with Olympiad, so they just think this is a waste of time or something like that. And because our syllabus is very far away from the Olympiad, not very far away, but kind of not adjacent to the IMO curriculum. For example, in physics, it's kind of similar to STPM. So you learn stuff in STPM and you can apply it in the IPHO. And the teachers can also train the IPHO students. But for maths, it's kind of very separate. So I really hope that we can get teachers to be one of our trainers in the future. So that's another hope of mine. I really want teachers to be able to train IMO students. Probably not to IMO level, but basic levels. Okay, so that you can get um, an appreciation from teachers about the IMO, as well as early nurturing from teachers. So there's so much us trainers can do. We can't teach all the students in all of the schools. We can only select some of them. So probably teachers can kind of contribute and train their students before they do their IMONST, for example. That would be a good start. Or probably we can call one of the teachers to be one of the trainers for us. Okay, like Madam Chin for physics. She teaches STPM, but the IPHO people can um, contact her to train the IPHO students. So I really hope that is possible in the future for maths. Okay, Malaysian route to the IMO. So I've talked at length about maths. I've I complain about stuff, lots of stuff. Let's talk about how you can go to the IMO. Okay, this is a general IMO timeline. So usually we start with IMONS. IMONS is new. It's just 2 years old. We only had two IMONS so far to replace OMK as a selection test. So the date may vary because we still haven't found the ideal time. Okay, because IMONS and the pandemic shifts school around, shifts exam around, so we had to shift IMONS around as well. Okay, so we don't really have the ideal time for it yet. Okay, ideal permanent time for it yet. So our aim for this year is May. Okay, and the details is it's an answer only test with 3,000 plus participants. And from there, we call 300 students for written tests. This is an IMONS 2, all right? So probably a month after. And then there's an IMO seminar, basically what I talk about uh, now, but shorter, to give the students what to expect, to tell them what's in store for them, and so on and so forth. There's about 100 students. And the same 100 students will go for the first training camp, which is what's going on now. So during the OMK Persama time, they have a week long camp where they teach everything in 1 week, and then there's an exam at the end. But with the new management team, with Ivan, with Zisong, with Zikian, we have discussed and we thought probably it's better to have a weekly thing. So we teach the student on on Saturday, give them problems and then homework, and then a test next week, the following week. So it gives them more time to digest the material and try some homework problem themselves and get used to it before the test. Okay, so this is what we've been doing this year. So hopefully we can see some positive things coming out of it. And then from there, we select 60 for more training camps, and then more training camps, be more 3, 12, and finally the final 6 in the IMO. So along the way, there are lots of competitions, international competitions. They are also not for profit. So these are for free as well. So there's APMO, TOT, and JBMO. So for
That's
this
easier.
year, this is the expected dates.
Right?
So I'm on one. So no, this is this past year. Sorry, the past year. So we had IMONS last year in August. IMONS 2 in September. IMO seminar in December. And BMO is now until next month. And then BMO 2 APMO and BMO 3 TOT are in March and April. And hopefully we have a lot of time to train the final 6 for IMO 2022. Okay, this is for this year. So
So
for
for students participating in 2022, when would they expect the IMONs to be held?
so if you want to participate in IMO 2023 next year, the selection will start May this year.
Right.
Okay, so hopefully this is the timeline that we are projecting, but hopefully we can stick by this. but the rough one is this one is
Around
for
when IMONS is starting to roll out, the government will perhaps send a mail to like a letter to all of the schools to
yeah.
invite them.
So in the first IMONs, we got 5,000 participants because the government sends out letters to schools. But in the second one, we only have 3,000 participants because KPM didn't send out the letter to schools because the schools were closed. Okay.
I
So
see.
that was a problem. So hopefully, for the next IMONs in May this year, we have more participants from KPM.
So regardless
Okay.
of whether the school receives any mail, so as long as the participant is wants to join, he or she can always ask the teacher to register, regardless
Yeah,
of. Yeah, okay.
and it's not the teachers. They don't have to register the students. The students can register for IMONs themselves. So it's not
No need
dependent
to
on the
go to
teacher.
management. Like
Sorry.
they don't need to go through a management, like the school management
No,
administration. I see.
no. You can just register personally,
That's great. That's great.
but it's good for teachers to like disseminate the
Yeah,
knowledge, the information to the students.
it'll be great.
Okay.
Because
So
I
this
heard
is
from some
sorry.
schools, like I heard from like some circles that there are schools that are like avoiding the work of extra burden to the teacher. So like this type of competitions, they won't announce it. They won't disseminate this type of information like Olympiads to the students. So
Yeah.
even if that happens, if the student receive information online about these Olympiads, they can like uh, go register their participation without going through those type of school administration system.
Yes. Yeah. You don't have to go through school, but schools are welcome to register their students in the students for them. Okay, so we had schools who registered about 20 students last year. So you can do bulk registration where the school registers 20 students at once. So you can do that as well. But yeah, it's open. You can register yourself if you don't want to register through school. Okay, so let's talk about IMONs. IMONs very recently introduced. Just this is the we just had our second IMON, second round of IMONs. There are two stages. One is school level and one is national level. Okay, so IMONs one is school level and then IMONs two is national level. So IMONS 1 probably will be held sometime in May 2022. There are three categories: primary ages 10 to 12, junior 13 to 15, senior ages 16 and above. And we do the registration via Contest Hub. So the teachers can register for the students, or the students can register by themselves on Contest Hub. And we always put the details on our website and on our Facebook page. So we have two sites that we regularly manage, the website and Facebook page. Um, and then contest is done on the web contest website. So this is where we have to ask someone from the Netherlands to make a contest site for us, and that costs about 20,000 ringgit. So it's online, so the students just go there, log in their details, and then answer the questions. And then at the end of the time period, the questions will be sent to us. Okay, so and then it's automatically graded as well. So there's no need to for us to do the grading. So that saves time on our end as well. And it's an answer only question. It's not multiple choice, it's answer only. So you put in a number in the answer. You don't need to do the working, you just need to put the answer. And the answer is during period is 2.5 hours. So the main reason or the main aim for IMONS 1 is to find the students who have already a good grasp of the basic knowledge in maths. Okay, so it's not to test your reasoning skills or anything. We just want the students at least know how to calculate stuff. Okay, that's IMONS 1. So there are 20 questions in four parts, and each part would have different difficulty. And the topics are number theory, algebra, combinatorics, and geometry, same as the IMO topics. And the subtopics are properties of integers, prime numbers, so students should know what prime numbers are, divisibility, and modular arithmetic. So this is kind of different from school stuff, but we always have the live sessions on our Facebook page. Okay, so we talk about this topic where the students can follow and learn new things. Okay, this is mostly
So for,
computational.
for sorry, doctor, but so for viewers of this video, if you want to check out the Facebook page of IMONS, you can click on the link that we will add on this video right now in the annotation. So,
Okay,
yeah,
so I've put a link of it at the
yeah,
end of the
yeah.
slides as well, so you can follow that. Okay, and we also have lots of past videos from last year and the year before, so where we talk about the same things. Okay, so you can just follow them there. And then there's algebra, algebraic expressions, factorization. You should know how to factorize stuff, equations, polynomials, inequalities, sequences, and functions. All right, so these two last ones are probably for senior students. Combinatorics, pigeonhole principle, something that is very straightforward and any primary school student can understand. Permutation, combination. So this is for junior and senior. Geometry, measurement, circle, triangle, quadrilateral, polygons, similar figures, geometric transformations. Okay, so these are the topics for IMONS 1. For IMONS 2, we pick about 300 students from IMONS 1. So, sorry, the previous one is for school level. So the certificate that you get is school level. Some of the teachers are quite angry with us when we give them school level certificate because they thought it's a national selection test, so it should be a national level certificate. No, this is a school level, okay, because we want to test the knowledge of the students from school, okay, not at the national level. So this is the national level, IMONS 2. At about 300 students will be selected for the next part 2. Again, there are three categories. This is a written test taken online. So you download the test paper, you answer it, and then you upload your answer on Google form. And the duration is 4 hours, so it's kind of like IMO style, but the questions are much easier. Okay, so the reasoning and working must be shown. So in contrast to the first IMONs, you have to write down your reasoning. So now we are testing you on your written part, your reasoning skills, your convincing skills. Okay, whether you can convince the examiner that you know what you're doing. And there are 6 questions from the similar topics, but may come with extra reading material. So we give you extra reading material and you read them before IMONS 2 and then just answer IMONS 2.
So
Okay.
contestants who have been shortlisted to IMONS 2 will have their answers and workings marked by the committee, like you, Dr. Shafiq, and the trainers.
Yeah, so I would do some marking, Mrs. Zafi would do some marking, Ivan would do some marking. So usually it's very quick because there are only 300 scripts. Uh, so it'll probably take a week. And we just select the ones that we think can write well, and yeah. And then after that we have the BMO, the Bankil, the workshop. So like what's going on now, it's a weekly online workshop, Friday and Saturday. We meet some of the trainers. We have a test in the morning from the subject, the lectures from the previous week, and then lectures and problem solving sessions. So we have 2 hour lecture and 4 hours problem solving sessions where we give you questions and you do them and you can discuss with us. And we gave also reading assignment and homework during the week before the test the following week. Okay, and because BMO is kind of new, last year it was quite a mess because we didn't have a system. But this year, with Mr. Ivan and Mr. Zisong on board, we have a really nice system. Okay, so we created a Discord server to get the participants in there, and they can virtually socialize with them. This is to replace the face-to-face camp. So they, in face-to-face camps, they can socialize with one another, but it's all online now. It's all at home now, so they can't socialize with each other. So we created this Discord server. They can talk to each other, chat with each other, chat with the trainers, chat with their friends, and also we can put information in there that they can probably you have reading material, homework assignments, tests, and so on and so forth, where they can download them. So it's a nice system. It's working nice so far. So probably this could help us in the future as well. Because previously all the BMO are all done face to face, and the logistics is quite big. You have to find a place to accommodate everyone, food, transportation, and everything. But now it's all online. It's easier, and they can socialize everyone. It's with everyone, but it's not as good as face to face socialization. Um, but that's the best that we can do. Okay. Uh, so this is a step for us to kind of create uh, an intellectual community, a mathematical community. They can talk to each other, and then Mr. Ivan set up some problems. These are unrelated to the BMO training stuff. These are just some interesting maths problems, and they can talk to each other about it. They can discuss with each other. They can collaborate. They can um, I don't know, ask questions. Okay, so it's kind of a step for us to create this intellectual community, because these students, they might be the only one in their school, so they felt a bit alienated. They don't have anyone to talk about in their school, to talk about maths with in school. So having this Discord server is good for them to
So it's
see
like,
like-minded students.
yeah, their community lah, like people like them who like maths and all those things. So it's
Yeah,
a, I see.
so it's a nice initiative by Ivan. Okay, and selection criteria. After that, we select all after the next stages. Depends on daily tests, final tests, and homework. And in later stages, the selection will also based on these other competitions. So you see that in BMO 2, there's APMO, there's TOT, and we are currently trying to get as many international genuine maths competition as possible. So there's APMO, there's TOT, and there's Iranian Geometry Olympiad, and we are trying to get JBMO, a Junior Balkan Mathematical Olympiad, and lots of other competitions as well. So these are genuine competitions. No fees are required, and the questions are of really good standard. Okay, they're real maths. They are not computation or multiple choice or whatever. These are really good international competitions, and they are, yeah, we approve of them. So we let our students to join them, and also the selection in the later stage will depend on their performance in these competitions.
So, Dr. Shafiq, like even students who doesn't make it to the final four-person team in IMO, as long as they get into the stages of the Asia Pacific Mathematics Olympiad or the International
Yes.
Tournament of Towns, they can actually get like PAGSK marks for peringkat antarabangsa
Yeah. So
diplomas.
these are all international competitions, and they will get, of course, international certificates, PAJ, SK, with Antarabangsa, and they get to participate in this. So APMO is for BMO 2, I think, and TOT is for BMO 3. Where is it? Yeah, here. And IGO is somewhere later in the year. So IGO is about 20 students. So we just pick from the students from here who gets who did really well in geometry. And also there's JBMO. JBMO is for junior students. That is quite new this year. Thanks to Mr. Shamil. Mr. Shamil has been contacting these people at JBMO and asking whether we can take part. Um, so we still haven't got a mechanism for this competition, but I think we are in now. Thank you to Mr. Shamil. But this one's for 20 people. So yeah, even if they don't get to the final six, they would have experiences competing in international competitions, and these are free. Okay, so APMO, what is it? It's an annual contest taking place in March. It's for Asian Pacific countries, but it's opening up to lots of other countries as well. It's taken locally at a contest center. So when I was a student, when I was in 2009, we had to do it in UITM, and or you now we can just do it at home. So it's 5 problems in 4 hours. It's not as difficult as IMO, but should be natural at the stage of training. It should be at BMO 2 level. And TOT is from Russia. It takes place twice a year, spring and autumn. Takes again like APMO, you do it locally. When I did it, it was at UITM as well. And there are 5 to 10 problems, and marks are not equal. So you have to choose which problem you want to do. Only 3 of your best scored problems are counted, and there are 2 different papers. So O levels is very easy. It's probably for junior students, and A level is quite difficult. It's a question paper from Russia. So what do you expect? It's A level one is quite difficult. And yeah, so that's it. That's my talk for today. It's gone on for 2 hours. Sorry for taking up your time. I got carried
It's a
away.
very enjoyable 2 hours. It's okay. I think we had a very good discussion on a lot of topics, not only on IMO but also on mathematics and the Malaysian scene, the Malaysian Mathematical Committee as well, which is a very good discussion.
Yeah.
And also for viewers, our viewers, students, parents, schools, if you want to learn more about IMONS or about IMO Malaysia, you can just click the link that we put on our video right now. And yeah, thank you, Dr. Shafiq, for this very interesting talk. But before we go, actually, I still have a few special requests, questions
Okay.
for you, not just about IMONs, but in maths and Olympiads in general. So, like, a few students ask, like, since IMONs tests about mathematics, real mathematics, like what you said, real mathematics outside of the school syllabus, like pigeonhole principle or number theory, the prime numbers, and these are not taught in the school syllabus. So how can students from like public schools prepare for them? Like, is there any free online legal resources, and where can they find it?
So most of these stuff in IMONS 1 are taught in school. So for example, prime numbers are definitely taught in primary school. So I remember them, but it was not emphasized at all in primary school. They just tell you this is a prime number, and that's it. Okay, so a good reference would be there are lots of material on our website. So we have some notes on basic things, and also we recommend some books. Okay, so these books are about there are books written by Mrs. Waimi. So Mrs. Waimi wrote 4 books, and for one for each topic, and they're really they would give you a good starting point to all these knowledge. So pigeonhole principle is just for example, it's just a way of thinking. So you can just go to Wikipedia and it explains to you what it is, and there's a picture of it. There are 9 holes, and then there are 10 pigeons, and yeah, you can see it. It's like, yeah, that
You
makes
just
sense.
explain pigeonhole principle, right? It's actually like you just explained it. It's actually not
Yeah,
as
so
simple as what people think.
yeah, so it's just you have 9 holes and 10 pigeons. At least one of the holes must have at least 2 pigeons. That's it. So you can use this is a it might be something silly, but you use it a lot. Even in IMO 2000 in last year, IMO 2011, question one was pigeonhole principle. So it is a principle that is you look at it, it's like, yeah, it is obvious, but how do I use it? Well, you have to learn how to use it. Yeah, lots of books and references you can find on our webpage.
All right. So
So
yeah,
please.
anyone interested in preparing for IMOs can just go to the link that we have in our description or right now there, on our video for the resources at the IMOs page. So actually, there's a few personal questions that I have. One of it is about the contest infrastructure for IMON. So you mentioned that every year IMONs need to pay like 20,000 ringgit to the Netherlands company for the contest infrastructure. Like, can you talk a bit about that? Like, why don't we have local contest infrastructure that supports it?
So probably this is kind of embarrassing. But if you have joined IMONS 2 years ago, we used the local 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 website, but it didn't go well, and it just crashed, and we had to. Yeah, it was embarrassing for me. All the parents are complaining that it's really bad, and I had a really bad weekend
And
that week.
must be
And
very frustrating.
then yeah, we just had to find a new website, and so I had a friend in the Netherlands who does all these things. And then we told to the parents that okay, we're going to set up the website for next weekend, and yeah, we're going to use a new website. So we worked for a week creating new questions, and ended up having to pay 20K for that new website. And
In
then
Singapore,
last year we just realized that we know how this works already, and we are confident that it works. So let's just stick with it. But this year, we're not sure. Maybe there is another. So I mean, said there's some. There is another website, a local website that might be useful. So we have to. Yeah, we have to explore. I mean, we are kind of new to it. This I am kind of new to this thing, and the IMO Malaysia IMO Committee is new to the scene as well. So what we're doing now is just we are trying to make things work. Yeah, trying to get a handle of how this thing works. I mean, even IMONs we had to shift around the date. On top of the pandemic as well, there's no certainty for us even,
oh,
so we just kind of
oh,
have to
that's
wing it.
yeah. So like the pandemic have helped you transition into like an online version of IMOs. Like a lot of people can have access to like the having taking IMOs at school at home. So it doesn't really matter whether well the logistic. You don't need to plan about the logistics of the papers because
Yeah.
that was before IMOs OMK was paper based, right? Right.
Yep. So before that, OMK was done in person in some test centers. So they have lots of test centers, and schools have to bus in their students. But IMONS, since its inception, all has been done online. So we see the good and the bad of it. The good is, of course, you don't have to get the students in one place. The bad is, of course, the system might fail. That's just a nightmare. And also, there's another problem of cheating.
Yes. But how can you cheat in like IMOs? Like if even if you have like all those mathematical textbooks, do you think like uh, people with textbooks but without mathematical reasoning beforehand can answer them? Do you think like cheating in
um,
IMOs is that prevalent?
IMON's one is answer only, so cheating is quite prevalent for that one. And some parents even complained to us they found some of the questions on a homework um, solving website, Chegg or something like that, Chegg.com. Yeah. So there's nothing that we can do about it. That's a problem with our there's a problem with our people, I guess. There's no the ethics and morality of people. We can't really do much about it. Um, Even IMONS too. For me, I am very sensitive to details and stuff. So when I mark the students' paper, I can immediately catch 5 or 6 students who copied off each other, and most of them are like siblings. So
Ah,
so that's a problem with that. And then I just contact their parents saying, can you confirm with this? And then they said, oh yeah, sorry about that. So yeah. And now in the training camp, you have that problem as well.
ah,
So moving online, there are some positives, of course, but there are also negatives. But yeah, we don't really know how to deal with them yet. We try to make them do the tests with the camera on, but for IMONs, we can't do that because there are 5,000 students
yeah.
and we can't monitor everyone. So yeah, we still have yet to find a solution for this. So one of the
But
problems was because
you,
IMONS was open for 2 days.
yeah.
So the period where you can answer this question is 48 hours. This is because some students say, oh, I have classes this day. I have to go to this. I have classes on Sunday, blah, blah, blah. So all the students have their own problems. So we have to make do by making the time limit long, so that they can just choose to sit for it whenever they can and whenever they want it. But it comes with a price, of course, the cheating.
Yeah.
So
So,
probably we can just limit the number of hours to like 8 hours or something like that.
but you think like the online version of IMONS will be here to stay?
Um, so far, yes, I think, and also the training camp, the first one at least, because we have 100 students. Um, we think that Discord helps a lot because you can see the interaction between them. You can disseminate all your material, and then you can record your lecture, put it on Discord, and um, they can call you and video call you whenever they have problems or stuff like that. So it helps with 100 students, but this doesn't replace the good old face-to-face camps. So what we're thinking is we're going to keep the camp to be on Discord, the first one, but when you have fewer students, probably like 30 or 15 or 24, it's more feasible to have a camp, a physical camp. So it's the best of both worlds, hopefully.
Face to face is always better than virtual if we have the
Yeah,
chance.
yeah, yeah. I mean, even teaching university classes, I find teaching on online is very frustrating.
Yes, yes. Okay, and something for viewers. So even if you're not in BMO, if you want to learn more about maths or Maths Olympiad or the IMONs, we have alumni in our Discord server from IMO, and it's not specifically for BMO or Asia Pacific Maths Olympiad. But if you are just a student interested in maths or IMONs, you can just join our Discord right here, right now, or in the description below. So it's free for everyone to join, even if you're a parent or school teacher. There's IMO alumni there to answer your question. So I think that's it from me. That's all my questions. Dr. Shafiq, do you have anything else to add on?
um, Not for now. But yeah, I don't think I have anything to say. I've said everything that I wanted.
Okay, so yeah, it's a very pleasant discussion with you. I think I learned a lot, not only about the details of IMOS, but also a lot about what you think about the Malaysian education, all those things. Yeah, I believe I got a lot from you. So thank you for coming to AMISO today. Thank you for joining us here, and perhaps we will meet sometime soon if we have other events.
Yeah, if the pandemic is well, I don't think it's going away, but we have to live with it. We have to
All right.
live with it.
So thank you, Dr. Shafiq, and
Thank you
thank
for having
you.
me.
Yes. Uh, Dr. Shafiq, you can hold on for a while. Jinxing, you can stop the recording.